Good morning, all of you. Now we are going to take the basic topic in signals and systems. The basic topic is to discuss the basic signal types. There are basic signals like unit step signal, unit impulse signal, unit ramp signal, and so on. Now we will cover all these signals one by one. So let us now begin unit steps of function. Unit step function, or it is also called as unit step signal. Okay, what is unit step function is? Unit step function is mathematically defined as u of t. U of t is equal to 1 for t greater than or equal to 0 and is equal to 0 for t less than 0. So mathematically it is defined as u of t is equal to 1 for t greater than or equal to 0, u of t equal to 0 and t less than 0. Now if you see the diagram of unit step signal, it is like for t greater than 0 it is 1 and for t less than 0 it is 0. So the diagram of unit step signal looks like this, and this is the best test signal. And why it is unit step is the amplitude of the unit step signal is 1. That is why it is called as unit step signal means the amplitude is unity. Okay, now coming to unit impulse function. Impulse function is denoted by delta of t, and how it is mathematically it is defined as delta of t equal to 1 when t equal to 0 and equal to 0 when t not equal to 0. Means what is the meaning? When t not equal to 0 means when except this point all other points are 0, and at this point at t equal to 0 the amplitude is 1. So it is called as unit impulse function. And what is unit impulse function? Once you integrate unit impulse function you will get unit step signal. Okay, and according to this equation, if you differentiate this equation, differentiation and integration will cancel, and delta of t is equal to du of t by dt. So these two are very important equations in signals and systems. Now coming to ramp signal. Ramp signal is denoted by r of t, and it is defined by r of t is equal to t greater than or equal to 0 and r of t equal to 0 when t less than 0. Okay, now if you see when t greater than or equal to 0 it is t. So it is a line inclined 45 degrees with this t axis. So it is something like it is y equal to x in mathematics. So r of t is equal to t when t greater than or equal to 0 and is equal to 0 when t less than 0. When t less than 0 it is equal to 0. So the graphically it looks like this. Mathematically it is defined like this. Okay, now u of t is equal to 1 is equal to t is equal to r of t. Now what is the relationship between unit step signal and unit ramp signal is ramp signal is integration of unit step. Ramp signal is integration of unit step, and unit step is equal to differentiation of ramp. Now the next coming signal is parabolic signal. Parabolic signal is defined as x of t is equal to t square by 2 when t greater than or equal to 0 is equal to 0 when t less than 0. So once you watch this you can visualize the mathematically it is like this, and graphically it look like this. This you might have undergone a math course in first year where you will teach where they will teach to sketch parabolic functions like this. Okay. Now, now what is the relationship between parabolic signal and unit step signal? Parabolic signal is t square by 2. That we will get by integration of ramp, and ramp I will get ramp t when you integrate unit step. So it is u of t, is equal to d square x by dt square, and r of t is equal to dx of t by dt. Right. Now coming to signum function. Signum function is mathematically defined as is equal to 1 when t greater than 0, is equal to 0 when t equal to 0, is equal to minus 1 when t less than 0. Now if you see, it is 0 at origin, but greater than 0 it is 1, and less than 0 it is minus 1. This unit, not unit, it is a signum function. The signum function is also can be expressed as in terms of unit step signal 2u of t minus 1. 2u of t is minus 1. This is a very important equation, because we'll see in the derivation of signum that it is defined like this. Signum of t is equal to 2u of t minus 1. Now exponential signal. Exponential signal is of the form x of t is equal to e power alpha t. Okay, and based on the value of alpha, the shape of exponential, the graphical shape of the exponential is defined based on the value of alpha. If alpha is equal to 0, then x of t is equal to 1. E power 0 is 1. Anything to the power of 0 is 1. So x of t is equal to 1. Now, if alpha is negative, that means x of t is equal to e power minus alpha t. The shape is a decaying exponential. As t tends to infinity, it goes down to 0. And when alpha is positive, it is a rising exponential. And as alpha greater than 0, as t tends to infinity, the value of x of t also goes to infinity. Okay. Now rectangular signal. What is the rectangular signal? Rectangular signal is defined as a rect r by t. R by t means the width of the rectangular pulse is t, then it is defined as a is the amplitude of the rectangular function, and t is the width of the function. So it is defined as a rect t by t. Okay, and if suppose it is shown as 4 rect t by 6, then how it is defined is minus 3 to plus 3, and the amplitude is 4. Okay. Similarly, you have a triangular signal. What is triangular signal? The triangular signal is mathematically it is defined as a of 1 minus mod t by t, or x of t is a times of 1 minus mod t by 5. So from minus t to t minus t to t duration, it is defined as a rectangular pulse, and the peak is a. Now if it is a into 1 minus mod t by 5, then it is minus 5 to 5, and mod the highest value is a. Okay. So sinusoid signal. What is sinusoid signal? A sin omega. The sinusoidal signal is of the form a sin omega naught plus phi, or a sin omega naught, a cos omega naught plus phi. It is a sinusoid. We all know that it is a oscillations, sinusoidal oscillations are there throughout the time. Okay, now sinc function. Sinc function. Sinc function is defined mathematically as sine pi t by pi t for is equal to 0. For t equal to 1, 2, 3, it goes on taking sine pi, 2 pi, 3 pi. So these all values are goes to 0, and in between you will have oscillations. Okay. Then sampling function is similar to sinc function. You can go through these notes and you can study, right? Okay.